A sequence is a list of numbers that are in a specific order. When you look at a sequence, you're going to be able to continue that sequence because there's going to be some sort of pattern to it. Okay? And there are two main kinds of sequences we talk about. The first is called an arithmetic sequence. In an arithmetic sequence, the difference between two consecutive numbers, the two numbers that are next to each other, is always going to be the same, and it's always going to be a pattern that uses either addition or subtraction. So if you look at this pattern here, and I try to figure out what's going on, to go from number to number, I'm adding 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, and so on. Since it's constantly adding and constantly adding the same number, that would be an arithmetic sequence. Now, arithmetic sequences can also be subtraction. So here's an example of a subtraction one. To go from 33 to 29, I see my numbers are getting smaller. So I know I'm not going to be adding. So I think, okay, maybe this could be subtraction. So if I look at that, I'm subtracting 4. And then 29 minus 4 gives me 25. 25 minus 4 gives me 21. And again, constantly subtracting the same number over and over again is going to be an arithmetic sequence. The other type of sequence we can have is what we call a geometric sequence. And this time, when you look between two consecutive numbers, the pattern is going to involve either multiplication or division. And again, it's always got to be the same amount. So if you look at these numbers, they're getting bigger and bigger. When numbers get bigger, you think it's either an addition pattern or a multiplication pattern. So if I go from 2 to 6, I might be doing plus 4, but that doesn't work for this next set of numbers. So I think, okay, not addition, let's try multiplication. So 2 times 3 gives me 6. 6 times 3 is 18, and 18 times 3 is 54. So this would be an example of a geometric sequence because it's constantly multiplying the same amount. And then again, look at one last pattern. We see our numbers getting smaller and smaller. Smaller numbers means that we could be subtracting or dividing. Subtraction doesn't make sense because for this set we'd be minus 200, but that can't be minus 200 because we'd be back at 0. So let's see if we're dividing by 2. 400 divided by 2 is 200. 200 divided by 2 is 100. 100 divided by 2 is 50. So again, constant division pattern means a geometric sequence. So this sequence here is one that is neither arithmetic or geometric, and you have to watch out for these. Look at this pattern. So if I think about this, I could say, okay, this looks like a plus 1 pattern. 1 plus 1 is 2. 2 plus 1, wait a second, that would be 3. So that doesn't work out. So it's not going to be an arithmetic pattern because it's not constantly adding the same thing. So let's try multiplication. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, but that's not 8. So it can't be geometric either because we're not constantly multiplying the same amount. This pattern's a little bit tricky. Look at what it is. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11. And the pattern continues. So this pattern goes plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Even though it's constantly adding, might make you think it's arithmetic, but because it doesn't add the same number over and over again, it is not arithmetic, it's not multiplication or division, so it's not geometric, so we say this one is neither. So what you may be asked to do in the long run is to tell whether each sequence is arithmetic or geometric, so you're going to have to look for those patterns, and you may find that they're neither also. You're going to be asked to show the rule. Showing the rule is like showing the pattern that you have, and then also you might be asked to fill in the next two terms. Figure out what comes next in your sequence. So let's do a couple of examples of that. When I look at this first problem, again, I see my numbers are getting bigger, so I might think it's addition. So if I look at this 4, that would be plus 8. Well, that's not plus 8, so that's not going to work. So I think, okay, maybe it's multiplication. 4 times 3 gives me 12. 12 times 3 gives me 36. 36 times 3 gives me 108. So it's constantly multiplying the same amount, which means this is going to be a geometric sequence. Now the last thing I need to do is I need to fill in those next 3 terms. So I'm going to continue this pattern. I'm going to do 108 times 3, which will give me 324. And then I'm going to do 324 times 3, which gives me 972. And that's how you come up with your next few terms, is you just continue your pattern. Let's look at this one. This one's a little trickier because we've got fractions. So 25, 22 and a half, 20, 17 and a half. I'm definitely getting smaller numbers. And because they're getting smaller, I know it's either going to be subtraction or division. And the change isn't changing enough. It looks like it's kind of a constant change, which makes me think this could be subtraction. If it were division, I'd have like a big change and then a smaller change, and they'd get a little bit different. The numbers wouldn't be so close together. So what I want to do is think, okay, what do I need to subtract to get from 25 to 22 and a half? And the way you can actually figure that out is do 25 minus 22 and a half and see what you get. And what you get is 2 and a half. So this pattern is minus 2 and a half. So 22 and a half minus 2 and a half gives me 20. 20 minus 2 and a half gives me 17 and a half. So remember up here where it said to show the rule? This down here is how we're showing our rule. So because it's constantly subtracting the same number over and over again, that's an arithmetic sequence. So we'll write arithmetic. And then all I need to do is fill in my next two blanks. So 17 and a half minus 22 and a half gives me 15, and 15 minus 2 and a half gives me 12 and a half. So one last sequence here to look at. This one goes 2, 4, 8. So I'm thinking, okay, my numbers are getting bigger. This looks like a times 2 pattern. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Oh, that doesn't work out. So it can't be a multiplication pattern. This must be one of those where we're adding this like different amounts. So this could be plus 2. This could be plus 4. This is going to be plus 6. Okay, so 14 plus 8 gives me 22. Then this is going to be plus 10. So is this going to be neither arithmetic or geometric because it's not a constant pattern. It's addition, but it's not adding the same number. And then to continue this pattern, we just think, okay, we did plus 2, plus 4, plus 6, plus 8. So my next plus 10 is going to be plus 12, which would give me 44. And then plus 12, then I go plus 14. And if I do 44 plus 14, I get 58. And that's how you would follow these rules to extend your pattern.